All right, guys, welcome back to lockdown. So thankfully we're at the start of a chapter, so we've got a nice easy concept to talk about today. And of course it's sine, cosine and tangent, or SOH CAH TOA. You guys remember this from earlier year levels, so it's what I like to call baby maths. Just in case you can't recall anything, you can watch this video and I'll talk through all the examples. So we'll start with a right angle triangle, identified by the right angle in the corner, and directly across from that right angle should be the longest side of the triangle, or the hypotenuse. And then depending on where the angle, the unknown angle, or you can see it's nominated here, the side next to it is called the adjacent, and the side opposite is called the opposite. Fancy that. Okay, let's have a look at the ratios. All right, so these are the trigonometric ratios. So this one is sine. The sine of angle theta is the length of the opposite over the length of the hypotenuse, or sine theta equals OH. So cosine of the angle is the adjacent over the hypotenuse. So you can see down here, cos angle adjacent over hypotenuse, or sometimes we call it CAH. And then tangent is equal to the opposite over the adjacent. There it is again. Tan theta equals the opposite over the adjacent. Again, that shortcut, SOH CAH TOA, helps you to remember the ratios, remembering that it's sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent is opposite over adjacent. Now, before we go anywhere else, can you please make sure that your CAS calculator is set to degrees and not radians? I'll show you that in just a second. Now, when you look at your calculator, you should be able to see a little thing, DEG, right there. You see how if I hover my mouse over it, it appears? It should always appear on your calculator screen. If it doesn't, you need to go to the home page, you need to go into settings, document settings, and make sure that the angle is set to degrees, and then make that default. Okay, here's the first example. Give the lengths of the hypotenuse, the opposite and the adjacent side in the triangle shown, and write the ratios for sine theta, cos theta, and tan theta. Here's the first example. We're supposed to find the lengths of the hypotenuse, opposite, and adjacent sides of the triangle, and then write the ratios for sine theta, cos theta, and tan theta. All right, when we look at our triangle, we have to use the given information to figure out what side is what. Here's a right angle, which means that 5 is our hypotenuse. Here's our theta, our unknown angle, and opposite it, this side labeled 3 is our opposite, and next to it, this side labeled 4 is our adjacent. So let's write that down. Right, so we've got our 3 sides identified. Now let's do our ratio starting with sine. Now sine theta, if you remember SOH, is the opposite over the hypotenuse. So that means it is 3 over 5. Cos theta, CAH, C-A-H, is the adjacent over the hypotenuse, so that is 4 over 5. And then the tan theta, TOA, is opposite over adjacent, so that is 3 over 4. That's all you have to do for that question. You don't actually have to work out the angles. Okay, so for the next example, I have to use my graphics calculator to find these values. So sine 49. So let's go to the calculator. Sometimes with this sort of question, it's quicker and easier to do it on your scientific calculator if you have one. But if not, in the CAS calculator, you have to click on the trig button here, and it brings up a menu with lots of options. We want to figure out what the sine of 49 degrees is. So we just type in that, hit enter, and we get 75.47 degrees. Now the question does say correct to 4 decimal places, and it was 0.75471. So I've got to decide, does the 7 stay a 7 or do I round up to an 8? Because the next value is less than 5, it stays as a 7. The next question is cos 16, so I'll get the menu, type in cos 16, hit enter, and that's the value it gives me. And the last one is tan of 27.3, so tan 27.3, enter, and there's my value. All right, let's take these values and round them off. So cos 16 is equal to 0.9613. The 6 that occurs after the 2 means I have to round it up. And tan 27.3, 0.5161. And that's fine the way it is. All right, in this exercise, you're also going to have to find length of unknown sides and missing angles and right angle triangles. The most important thing to do when you're solving it is make sure that you draw the situation using a right angle triangle and label what you know. If you don't draw it and you just try to do it, envision it in your head, it creates a greater potential for mistake. Label your triangle with opposite, adjacent, hypotenuse. Identify your relevant sides, and that'll help you select your trigonometric ratio, and then substitute your information to find the unknown. So let's have a look. Example A, we have to find x in the following triangle correct to 2 decimal places. Now here's x, and we need to have a look at the information that we have. So we've got a picture of a triangle. Let's start by labeling our sides. We can see that opposite the right angle, over here, we've got our hypotenuse. I'm just going to put a H there. Here's our angle, which means that the side right next to it is adjacent, and x is on the opposite side. So we're going to use the sine ratio because we are looking for the opposite and we have the hypotenuse. So let's set that up. The first thing I do is write the ratio that I want to use. So sine theta equals opposite over hypotenuse. Now I'm going to substitute the information that I have. So I have the angle and I have the hypotenuse. And when we substitute those in, we get sine 29 degrees equals x over 7, and we're looking for x. We're looking for x, we want to get it by itself, so we've got to get rid of that dividing by 7. So let's multiply both sides by 7. These guys cancel out, so you end up having to type into your calculator 7 times the sine of 29 will give you x. So on your calculator, you type 7 times the sine of 29, and it should give you a side length of 3.39. All right, so we found x. We've got to write it correct to 2 decimal places. So x is equal to 3.3. We're cutting it off there. The next number is a 3, so we don't need to round up. So it's 3.39. We don't have units, but please don't forget units should you be doing it in a situation where you do have units. Okay, our next right angle triangle. We've got our right angle there, which means that 10 is our hypotenuse. There's our angle, and there's h, which is opposite. So we're going to be using the sine ratio. And the information we have says that it's sine 40 degrees equals x over 10. And we know that to solve that into our calculators, we're at 10 times sine. So let's do that. All right, so I entered that in, and I found that x is equal to 6.4. Here's our cutoff. 7 is things, so we're going to round it up to 3. And again, we don't have units, but don't forget your units, please. So 6.43 is x. Okay, we're looking for an angle to the nearest degree. Here's our angle. Let's label our sides. This is clearly our hypotenuse. This is our opposite. This is our adjacent. So we're going to use tan. Tan theta equals opposite over adjacent. Fill in the information that we have. We don't have theta, but we do have 3 over 2. Let's put that in the calculator. Now, before we can put that in the calculator, we do need to get rid of that tan. So what we're going to do is we're going to multiply both sides by the inverse of tan. Then these guys cancel out, and we're left with theta equals tan to the negative 1, 3 over 2. And that's what we'll plug in the calculator. Okay, when you look at your calculator, you're still using the trig function, and you can see it's in the second row, tan inverse tan. And it was, I think it was 2 over 3 or 3 over 2. Okay, it was 3 over 2. So we'll just put in our fraction, 3 over 2, enter, and we get 56.3 degrees. The question wanted us to round it to the nearest degree. You've got 56.3. 0.3 means it stays as 56. It doesn't get rounded up to 57. So the answer is 56 degrees. Okay, I think this is the last question I'm talking through. Again, let's navigate our way around this triangle. There's the right angle, which means 21.7 is the hypotenuse. There's theta, which means 13.6 is opposite it. So we're using the sine ratio again. So hypotenuse, substitute the information we have. We have got 13.6, 21.7. Now we're going to rearrange the equation. So sine is not with theta. So sine becomes inverse. We're doing 13.6, 21.7. All right, I'll pop that in the calculator and we'll see what we get. So again, to find the sine stuff, we are going here, sine -1. Why didn't it choose it for me? What's going on there? There we go. Sine -1, and the numbers I think were 13.6 divided by 21.7. Hit enter. There we go, and our answer is 38.8. Just going to get rounded up to 39 degrees. So our final answer is theta equals 39 degrees. So it did ask for the nearest degree. Okay, that's it. That's all the examples worked through. If you're getting stuck, please message me. But like I said, this is baby maths and hopefully most of revision. Good luck, guys. Yeah, you'll be fine.